Hello students. Now I want to discuss with you free radical addition reactions. So in this free radical addition reactions, so first free radicals only start the reaction. Free radicals start the reaction with unsaturated compounds. With unsaturated compounds. Okay. Next, in this process, in this free radical addition reactions, so these reactions occurs in presence of sunlight, h nu, or or temperature, or sometimes they will give the symbol is heat. So presence of these conditions only, free radicals only start the reaction with the unsaturated compounds. So that unsaturated compounds here either alkenes or alkynes. Now the one example, when CH3 CH double bond CH2. So this is the propane molecule. When propane molecule is reaction with HBr, HBr in the presence of R2O2 and H nu, R2O2 and H nu. So presence of it occurs in the presence of sunlight and given, and peroxides also important. Peroxides. Okay, presence of these conditions only this free radical addition reactions takes place. So in this free radical addition reaction now, so product formation. So what kind of products only it develops? Just addition of this one, but this Br is attached at this carbon atom. This hydrogen is addition takes place at this carbon atom. The final product is CH3 CH H single bond CH2 Vr. So the product is 1 bromo propane. 1 bromo propane is the product. Okay. So we will discuss mechanism also, how it will involving in the reaction. Mechanism. First, the first step. In step 1, first R2O2 involving in the reaction, ROOR. Now the electronegativity in between the peroxide is same. This oxygen electronegativity is same. Then what happens in the presence of H nu? So this bond will equally cleaves. That bond cleaves equally. One bond has 2 electrons. One bond has 2 electrons. Each one electron shifted on oxygen atom. So that time what happens? Free radicals only develops. Free radicals. So now this bond will cleaves equally. It converts into RO free radical plus RO free radical. Okay. Alkoxide free radicals only forms. Then the alkoxide free radical, it is unstable form. This one is unstable. The unstable form of this free radical. Next in the another one, further R alkoxide free radical reaction with the HBr molecule. So in this HBr molecule, then this one also has two electrons. The unstable form of this one attract the proton. Now this electron moving towards to alkoxide free radical. Now this group alone converts into ROH plus Br free radical. This is the further condition. Next, this Br free radical, in the next step, what happens? The Br free radical reaction with the alkene, propene molecule. That propene molecule. Next in this, when this CH3, CH double bond CH2 group, if it is reaction with bromine free radical, bromine free radical. So what happens here? We will discuss in the two paths. This is the first path. This one is the second path. So why we will discuss here in two paths. If a bromine free radical attacks on this carbon, this is the one way. The same bromine free radical attacks at this carbon, another path. Two paths we will discuss in this. If it is attacks on this carbon in the first way, then what happens here? This one bond, this one electron migrated towards this carbon atom, right? Now this one convert into CH3, CH free radical bond CH2 Br. This is the first way, first path. In the second path, if a Br free radical attacks here, this one electron migrates towards to this carbon atom, first carbon. Now the second path forms CH3, CH, Br, CH2 free radical. This is the one compound. In these two, the above compound is the secondary free radical. Now below one is primary free radical. Which one is more stable always? Secondary is always more stable than the primary. So the above compound only more stable. In the next step, the CH3, CH free radical with the CH2Br reaction with the further it is also again involves. Why? Because H only involving in the reaction. Why? Because R, O, H. Now this one absorb the proton again. So after absorption of this proton, this one bond with propane. Here, what is the propane molecule? Here developed a free radical intermediate. That one only forms CH3, CH bond H, CH2, Br. This is the final product. Again, this RO radical, one more radical, both combined to form again R2O2 peroxide. As a catalyst only it is elimination takes place. So this one is the mechanism of the free radical addition reaction. Okay, then now these molecules mostly follows anti-Markovnikov rule. Anti-Markovnikov's rule. So this anti-Markovnikov's rule is also called, other names also important. This is also called Karash effect. This is also called Karash effect, or another name of this one is also called Karash effect, or another one peroxide effect. It is also called peroxide effect also. Okay, based on that conditions, we will discuss few examples. Right. Then first example here. So what is the meaning of anti-Markovnikov rule or Karash effect or the peroxide effect? So generally the bromine free radical always attacks on the more number of hydrogen atoms. Okay, anti-Markovnikov rule means A, M, K means bromine free radical always attacks on more number of hydrogen atoms in asymmetric alkene. Asymmetric alkene. So this one is called anti-Markovnikov's rule. Anti-Markovnikov's rule. So according to that rule, so we will discuss now one example. Okay. So in this case, one more point also we will discuss, very, very important, that point. So what is that important point? HBr molecule only involves in free radical addition reactions. Free radical addition reactions. Only HBr molecule. Okay. So this one only involves in free radical addition reactions. Remember this point, it is very, very important. Only free radical. Okay. Only free radical only involves. So why this one involving in the reaction? I will explain now. One example. Yes, reason only we will discuss now. Now, in the first condition or the first step only I am explaining. C double bond C. It is the alkene molecule. This one is alkene. When the free radical is attacking on the alkene molecule. Okay, when free radical is halogen free radical attacks on the which molecule? Alkene. That time what happens? If the free radical developed from the HF, what happens? HF molecule and HCl molecule. Another one is HBr. Next one is HI molecule. HI. Then first case, when free radical is attacks on this alkene molecule, the delta H value, when the both close to each other, so that time what happens? It releases the energy. So the releasing energy is represented with the negative. So if this one also involving in the reaction HCl molecule, the delta H to release energy. When HBr also involving in the reaction, it is release the energy. But if HI molecule involving in the reaction, the delta H is positive. Delta H is positive. So it is a exothermic process. What about these three? Endothermic. Sorry. Sorry, ma. Now, if delta H is equal to positive means it is endothermic process. Now, the remaining three, these are exothermic process. This is the first step. First step only. Then if you observe in the second step, then what happens? After attacking of X only, now this group converts into like this. Here, free radical, this carbon, this one attached to the X. This is the free radical form. The free radical form, further it is reaction with the HX molecule. Further it is reaction with the HX molecule. Then what happens here? The same delta H value of HF, HCl, HBr and HI. In these three cases only we will discuss now. In this case, HF molecule is involving in the reaction. The delta H value, it is positive. That means what? It required energy. It required energy. When HX molecule is breaking, so that time what happens? We should supply the energy. That's why here the delta H value is positive. Then at the same time, HCl molecule involving in the reaction, for this molecule breaking also it need energy. But if HBr molecule involving in the reaction, the delta H value is negative. So Identify in this condition, it is a electron releasing case. Now, so the energy releasing case only delta H equal to negative. If you identify the last case also, delta H is equal to negative. So what did you understand in this? Finally, in these given conditions, now the delta H value is negative. In the second step, if you observe in the first case, the delta H is equal to negative. So both are the exothermic cases. Exothermic. So exothermic is only always more stable. Did you understand this one? Very, very important. In the delta H value negative means when energy is released by the given molecules, that one is always stable compound only. In this given free radical addition reaction, bromine only, HBr molecule only release in both cases. When X free radical attacking on the alkene, after the formation of this free radical again a reaction with the HX molecule. So that's why here this one forms only HBr molecule forms are involved in the free radical addition reactions, but not the other molecules. So based on this condition, I will explain one more example. That is when CH3, CH double bond, CH2 reaction with the HCl in presence of R2, O2, H nu. Okay, peroxide in the presence of H nu. So what is the final product here? So now CH3, CH, Cl, CH3. That means my here HCl involving in the reaction presence of peroxide means now this one does not affects. Peroxide effect is not present in the presence of HCl molecule. So this one always follows which rule? Markovnikov rule. MK rule only it follows, and it is which kind of reaction? Electrophilic addition reaction, but it is not a free radical addition reaction. It is not a free radical addition. Only it is electrophilic addition reaction. You should remember this. Very, very important also. Then we will discuss few examples in this as per the AMK rules. Now exception case, that means HCl involving in this, it is not involving in the free radical addition reaction, only it involves in the electrophilic addition. Suppose one more example, CH3, C, double bond CH2, here CH3 given. When it is reaction with the HBr molecule, in presence of R2O2 and H nu. R2O2, H nu molecule. Then final product is in this. Directly it is attacks on the more number of hydrogen atoms present in the asymmetric carbon. More number of hydrogen atoms present in the asymmetric alkene in that carbon it is. So Br free radical attacks here. Remember that point. So directly we can write the product CH3, CH, here CH3, CH2Br. This is the final product. So in this given condition, in free radical addition reactions, in free radical addition reaction, there is no rearrangement. There is no rearrangement. It is also important. There is no rearrangement. That's why it is directly attacks on the more number of hydrogen in the given compound. Then another example. Suppose this is the 1-butene molecule. When 1-butene is reaction with the HBr in the presence of R2, O2, H nu, what happens? The bromine free radical is always bromine free radical. This one always attacks on the more number of carbons. Here this one has 2 hydrogen atoms. Here one only. So more here only. So add here bromine. Here hydrogen. This is the final product. Okay, like this. And another one, another example. Same kind of one more molecule also involving with the pH. benzene also there. CH double bond CH CH3. CH CH3. This is the compound. When it is reaction with the HBr molecule, presence of R2, O2 and H nu, sunlight condition. So what is the final product here? Here double bonded carbon atoms now present here one, here also one. If a bromine free radical attacks here, this one get the free radical adjacent with benzene. That is the more stable form. Now I will show you that stable form also. Here free radical CH Br CH3. This one is the stable form. Benzyl free radical is always more stable. So this benzyl free radical here after that which one attacks? Hydrogen attacks at this position. Hydrogen free radical attacks here. So finally add here one hydrogen. This is the final product. So this one another condition. Next example is simple one only. This one also. Cyclohexane here CH2 double bond. Here C double bond, it is CH2 group. When HBr is reaction with this molecule in the presence of R2, O2 and H nu. The final product is always bromine free radical attacks on the more number of carbon atoms in the given asymmetric alkene. So product is CH2 Br. Hydrogen attaches to this position. So this is the final product. So next another one we will discuss in the same conditions only. Now one more example. It is the double bond. Here one CH3 group is present. When HBr molecule reaction with this given compound cyclohexene, 1-methyl cyclohexene. Now presence of R2, O2 and H nu, sunlight. Just if you observe in this, here this carbon, very important this one, observe carefully. Here this carbon has 1, 2, 3, 4 bonds. So hydrogen atoms are less, 0 only present. But here this one has one hydrogen atom. Now which one has more number of hydrogen means this position. So that position means we can write the final product is the CH3 group. Already it has one CH3 group. Add here hydrogen. Why? Because less number of hydrogen. Here only more hydrogen. Add bromine. This is the final product. H and Br both added here. Remove a double bond. Add H and Br molecule. So this is the final product only. The next another one more example. If CH2 CH double bond CH2, here one NO2 group is given. NO2 group. When it is reaction with the HBr, presence of R2, O2, H nu, peroxide in the presence of sunlight. Generally, we should know that Br always attacks on the more number of hydrogen in this. But here one compound which is attached to the that asymmetric alkene, it is electron withdrawing group. Electron withdrawing group always decreases the stability of the free radicals. If it is decreases the stability of the free radicals means Br always attacks on the this carbon. If electron withdrawing group is present, so that time write the product in reverse manner. Okay, in reverse manner only. CH2, CH, here Br, CH2, H here, reverse only. your NO2 group is present. It is electron withdrawing group. If electron withdrawing group is present, so answer should be like this. Okay, it is very, very important. The next another condition here, one or two examples only we will discuss. If one more example, if CH3O CH double bond CH2, this is the one more kind of molecule. If it is reaction with the HBr molecule, HBr in the presence of R2, O2 and H nu. R2, O2 and H nu. In this, if bromine free radical attacks here, this one get the free radical form, free radical. So it is the releasing group only now. The group which is attached to the plus M case. In this case, it is electron withdrawing group. Now this one acts as the electron releasing group. If electron releasing group is present, now the product formation is CH3O CH H CH2Br. Same product only forms. Before, as we discussed in the given previous cases, same like that only product develops. So this one is the free radical addition reaction with examples. Okay, the next video we will discuss another reactions, type of reaction. Thank you.